I want to welcome you to the new project Pelagio that started last October and is part of the EcoWind program. It stands for Physics to Ecosystem Level Assessments of Impacts of Offshore Wind Farms. And you can see that there's an excellent array of academic and project partners. Now, in this short talk, what I'm going to do is go through the three main work packages and their objectives. And then I'm going to finish on a summary slide of all of the outputs and how those are turning into impacts. So to start with, we have work package 1, which is looking at the impacts of changes in mixing. What I mean by mixing is mixing up the water column from the effects of offshore wind structures, but also from the extraction of energy by offshore wind. And we're looking at this at 3 different scales, the local, regional, and shelf-wide scales. And one of the main things to determine is that these changes are outside natural variability and how they are relative to climate change. So at the local scale, we're going to be working with one of our partners, Marine Scotland Science, and using the Scotia and going out and collecting a lot of field data in terms of putting in moorings at different distances from a wind farm. At the regional scale, the wind farm we're going to work with is the SSE Seagreen in the Firth of Forth. And there we're also going to put in gliders, or AUVs, covering the area for several months. We're going to put all that fine scale data together and put it into shelf-wide models, that, in particular the FVCOM plus URSA models, such that we can look at the effects of wind farms and of climate change at fine to very large scales. In work package 2, we're going to look at the oceanographic processes that predict fish availability and how offshore wind farms might be altering foraging opportunities. We're going to be doing this by producing 2 new metrics, one called prey availability and the other one called the probabilities of foraging opportunities. Again, we're going to be working at the local, regional, and shelf-wide scales. So at the local scales, we're using upward facing active acoustics to look for fish that we're going to put out in our field studies near to turbines. At the regional scale, as I've said, we'll use gliders, but we're also going to use the NEODAS data to look at surface features of fronts and amounts of production in these areas, as well as looking at tagging data from seabirds. For the shelf-wide area, we're going to be using a sister project called PREDICT. That's from Ørsted. And here we're using all of the ICES data on fish as well as commercial data from fisheries, putting it together to allow us to move things to the large scale for fish predictions. In work package 3, we've got new methods to assess ecosystem level cumulative effects so that we can look at trade-offs without wind farms, fisheries changes, and climate change. The method of choice we're going to use is a proven dynamic Bayesian network model. We're using this so that we can have outputs across very different types of outputs, the ecosystem services, marine net gain, natural capital, and even gross value added. And again, we're going to test out these different scenarios at different spatial scales. Now, our main outputs then, work package 1 produces these new autonomous monitoring techniques, combining the moorings and the gliders. We're going to put that all together in a new way of looking at both fine and far field effects of offshore wind farms, but also climate change. In work package 2, this production of new fish availability metrics we think will be very sought after, as we'll have produced the mechanisms and reasons for these variations in our top predators like seabirds and mammals, and these will be the inputs below that. In work package 3, we'll be looking at cumulative population trends. As we put all of these effects and they go through all the trophic levels, it allows for this dynamic interaction. So once you get to your top predators, you have got the cumulative effects of all of those things when you're predicting your population trends. And as I've said, we'll do this with scenarios, with and without wind farms. We'll change the shape and size of wind farms. We'll do it with looking at realistic ideas about what fishing displacement might look like and how those changes also come through the system. And then, of course, with climate change, all doing that at different scales. Now, the ecosystem outputs will come out always bigger than the size of a wind farm. So to bring these things down and look at the trade-offs, we're also going to use what we call a modified habitat risk assessment model, the INVEST model, which is a model produced by the Natural Capital Project at Stanford that we're also collaborating with. So we can assess these trade-offs in space use at this very fine scale. So the impacts that all of these things will do is that it improves certainty in collision and displacement models. It identifies areas for compensatory measures. We can assess the levels of change across all of these things like marine net gain, ecosystem service, natural capital, and we can identify which areas are good, better or worse for offshore wind farms and more or less resilient to climate change. Thank you.
I'd like to give an overview of the Prepared project on behalf of all the project partners. This is a 4-year project which started at the beginning of 2022. It's funded through the Crown Estate's Offshore Wind Evidence and Change programme with additional support from Crown Estate Scotland and Scottish developers. The project is led by Marine Scotland Science and it involves multiple partners from both the UK and overseas, government, academic bodies, nature conservation agencies and industry partners. The overall aim of the project is to de-risk consenting by reducing uncertainty in cumulative impact assessments for future developments. Our focus is on top predators, marine mammals and seabirds, where the key concerns have been around for marine mammals, injury and disturbance from noise during construction, particularly from power driving, and for seabirds, collision risk with turbines and also displacement during operation of offshore wind farms. Over the last 10 years, as we've heard at previous ScotMER meetings, there have been developments in frameworks to predict the population consequences of these impacts for both seabirds and marine mammals. This includes frameworks such as DPONS and interim PCOD and Seaboard, and we'll hear more about some of those in a later talk on cumulative effects. Despite these advances, there are a number of uncertainties which constrain future consenting. These frameworks have only been used for consenting, and so far we really don't know how robust those predictions are when it comes to those wind farms being built. There's also uncertainty about how the predator communities and their prey might respond to the presence of new offshore wind farms, and so that uncertainty means that we're not clear how we should develop those assessment frameworks to consider cumulative effects when we start building additional wind farms adjacent to existing structures. So our approach in Prepared is to collect new data around existing offshore wind farms, both on predators and their prey, and to use this information to test and develop the assessment frameworks to better predict cumulative effects of further developments. Broadly, our objectives are to understand how prey behaviour, distribution and communities may change in response to new structures from offshore wind farm developments, to assess how those predators, seabirds and marine mammals, respond to changes in their prey and also the presence of the structures and other activities around the wind farms, and ultimately to explore how we can best incorporate that new understanding into cumulative impact assessments and the frameworks that are being used for consenting. The project is broken down into 4 work streams. The first of these involves data collection and field studies in the Firth of Forth, looking at predators and their prey in relation to wind farms that are currently being built. The focus here being on seabirds and the work around the Isle of May. The second work stream focuses on data collection in the Moray Firth, where the predators of interest are marine mammals, particularly harbour porpoises and their prey, and here the wind farms have been in place for several years now. Workstream C takes that new information and integrates it into assessment models and looks at transferability for use across other sites in the UK and further afield. And then finally, Workstream D focuses on dissemination of this information to improve our impact assessments and offshore wind farm policy developments in the future. What I'd like to do in the remainder of the talk is just give a few highlights from each of the work streams about work that's been carried out in this first year of the project. Under Workstream A, fisheries surveys were carried out by Marine Scotland Science in June, July, and then again in August, primarily in the Firth of Forth around pre-construction sites, with a little bit of work in the Moray Firth around existing wind farms. Unfortunately, the seabird tracking work that was to be carried out from the Isle of May by CEH at the same time as these surveys had to be cancelled due to avian flu, but it's hoped that this work will go ahead in 2023. The surveys that were carried out were fisheries acoustic surveys with some baited camera work, grab sampling and trawl samples, which also generated fish samples which are being used to look at the energetic content of these prey by ScotMER Consulting, and this will be incorporated into assessment models by themselves and BIOS for the seabirds. In the Moray Firth, prey work has involved fish tracking, where in April Marine Scotland Science and the University of Exeter laid an array of multiple acoustic receivers around turbine sites in both Beatrice and Moray East offshore wind farm, and a number of fish have been tagged with active acoustic tags, and this will continue over the next 2 years of the project as we look at movements of fish around the wind farm sites and how they use these new artificial reefs. Further work on the distribution and composition of prey communities around the new wind farm sites was carried out by the University of Exeter in August, using baited underwater video cameras, stereo cameras, which will allow the identification and measurement of fish at a range of sites around turbines of different ages and at reference sites. In parallel to Exeter's fish work, the University of Aberdeen put out an array of echolocation detectors to assess variation in the occurrence and foraging activity of porpoises across these sites in relation to structures and local fish densities. Data from this first field season are now being processed and analysed, and we're working with others in Workstream C to incorporate these into improved assessment frameworks. Also planning further field work for 2023 around construction sites in both the Moray Firth and the Firth of Forth. And we'll be presenting these early data at stakeholder workshops over the year. And if you'd like to find out more about the project, then please do get in contact with the project coordinators at Marine Scotland Science. Thank you.
Hello, I'm James Dargie, a Marine Information and Databases Advisor at NatureScot, and with my colleague Jonny Savage from JNCC, I'm grateful to be able to give an update on the Feature Activity Sensitivity tool FEAST to the symposium. FEAST project and associated application collate information on feature sensitivity, pressures, activities, and the evidence on which these are based. Governance is provided through the FEAST Working Group, which is a partnership between NatureScot, JNCC, and Marine Scotland and SEPA. The current FEAST application is hosted on Marine Scotland's website and has been live since 2013. An introductory FEAST homepage was published by NatureScot to help explain ongoing. Sensitivity assessments aim to ensure that information on the sensitivity, the tolerance and recovery for all Scottish marine features of conservation importance can be incorporated into FEAST. Assessments are undertaken against a defined list of pressures associated with known Scottish marine activities. The marine pressure list is adapted from an inventory prepared and agreed by the OSPAR Joint Assessment Monitoring Programme. The scope of species sensitivity assessments cover marine birds, marine mammals, fish, and shellfish and other invertebrates. For habitats, priority marine features, Annex 1 habitats, broad representative habitats, and other offshore habitats are covered, and there are also a series of geomorphological feature sensitivity assessments. The audience for FEAST is wide, and it's designed to be used in a variety of ways by anyone with an interest in potential impacts on marine features, for example, conservation advisors and consultants, developers, planners and other regulators, people who work in marine industries, for example, offshore development and marine renewables, fisheries, aquaculture, shipping, seaweed harvesting, marine tourism and recreation, and academia. Scotland's Marine Assessment 2020 used FEAST to underpin pressure assessments required by the Marine Scotland Act 2010, and FEAST is being used to inform discussions on management requirements for marine protected areas and priority marine features. Concerns with the current application are being addressed by the working group. In 21-22, work was commissioned, which reviewed previous analysis of the current application and processes, including information gathered through surveys and business analysis reports. A series of stakeholder engagements to confirm functional and non-functional requirements, capture gaps, and identify additional requirements were undertaken. These produced agreed requirements for future application, along with technical options for development, delivery, ongoing support, and maintenance. Outputs focused on wireframes of the system interface, data flow diagrams, data models, costed options, functional requirements, and the functional specification. This financial year, work has been led to build, test, and implement a new FEAST application according to the requirements captured in early 2022, to provide training and documentation to enable the updating of content in the application, to provide documentation to support end users, to host and support the redeveloped application. This work's in progress. It started in December and is due for delivery early April this year. I'll now hand you over to my colleague Jonny.
Good morning, I'm Jonny Savage and I'm a marine ecologist at the Joint Nature Conservation Committee. I'm going to be continuing on from James to talk about FEAST and the sensitivity assessments within it. As you've just heard, FEAST contains assessments for a range of Scottish features, from habitats to individual species. These assessments score sensitivity against a list of standardised pressures developed by OSPAR. All marine activities can be correlated to these pressures to determine how sensitive the feature is to the activity you are undertaking. An activity can be nearly any human interaction in the marine environment. To help us organise these, we categorise them into activity groups. These groups range from commercial fishing and energy production to military and recreational activities. Using FEAST, we can see which pressures are associated with specific activities. This allows us to only see the relevant sensitivity assessments. A pressure is defined as the mechanism by which an activity or natural event affects the ecosystem. The assessments within FEAST use this standardized list, or a slightly modified version of it depending on the feature, with each pressure having its own sensitivity score. Pressure benchmarks are designed to provide a standard level of a pressure to assess sensitivity against. These were developed by the MBA and include descriptors of the pressure in terms of magnitude, extent, or frequency. Sensitivity is comprised of two components. Recoverability is the ability of a feature to recover after damage from a pressure. This ranges from very low, where the feature takes at least 25 years to recover, to high, where full recovery occurs within 2 years. Tolerance is the extent of damage done to the feature at the pressure benchmark. This ranges from none, where 75% of the feature is lost, to a high tolerance, where there is no significant effect. Sensitivity is assessed by combining the tolerance and recoverability scores for each pressure for the feature, as seen in the table below. Some assessments are scored as sensitive if there's not enough evidence to provide a full score, but the evidence does indicate that the pressure negatively impacts the feature. This is a quick overview of the MBA's Marissa method, which most of the FEAST assessments are based on, either using this method or one adapted from it. Once the key elements of the feature are identified, we look for evidence on its recoverability and for its tolerance against a benchmark of each pressure. Confidence is assessed based on the quality and quantity of evidence available for each sensitivity score. This is a continuous process, and assessments are updated when new evidence is published to ensure that the sensitivity scores are as up to date as possible. FEAST really is a starting point for determining potential management measures within MPAs and can highlight where further discussions are required. The FEAST application is accessible to all, and it allows everyone to identify which features might be sensitive to a planned activity. This can help start discussions on how to ensure that these protected features aren't damaged, but the vital marine activities continue without negative environmental impacts. Thank you very much for listening, and if you have any questions, please feel free to ask in the Q&A session. Thank you.
Today I'm going to be talking about the Cumulative Effects Framework project, which is a large collaborative project funded by Marine Scotland for developing methods to estimate cumulative effects on seabirds and marine mammals in relation to offshore wind in the UK. So in the UK, the assessment process for seabirds and marine mammals varies, and it can involve a range of fairly complicated processes, ecological processes, and different sets of tools to arrive at an output. So this is an illustrative framework for seabirds. So we tend to estimate species distribution and abundances from various types of data, GPS tracking data or at-sea survey data. And these are then used within tools to estimate collision or displacement effects in different seasons, breeding season and non-breeding season. And then these effects are converted into population level impacts, which are apportioned to protected colonies and used within population viability analyses to then look at impacts for impacted and unimpacted populations and how demographic rates are affected. So this relatively complicated process has, to this point, led to a series of challenges in terms of estimating cumulative impacts for wildlife in the UK. The methods that are used to estimate different types of effects, so for seabirds, collision and displacement, have tended to be developed in isolation from each other, potentially by different groups of people. And the tools are disconnected, and there hasn't really been any cohesive strategy to try and link these tools together in a meaningful way, partly due to a lack of IT infrastructure needed to do this. And primarily there's really been this sort of focus on bespoke case studies where assessments have been done for perhaps just one species or one season, which has meant that wildlife impacts remain a key consenting risk for offshore wind in the UK due to these inconsistencies, uncertainty and delays. So in this project, we started out by having a really intensive period of engagement with stakeholders, and that has continued throughout the project. And the main messages that we had from stakeholders were that any cumulative effects framework needed to have transparency and consistency, and critically have a very clear audit trail produced for each assessment. That ideally there would be default settings that would have consensus agreement to sort of speed up the process where possible, but also that there needed to be flexibility remained. Some settings would still need to be user defined and fitted to the case study in question. And also that uncertainty, the characterization of uncertainty should be improved and carried throughout the assessment process and clearly presented at each stage. So the project has developed a cumulative effects framework, which has got three main parts: a data library, an integrative R package that links the tools together, and a user interface. And throughout the project, the emphasis has really been on this idea that a robust assessment of cumulative effects requires a consistent and transparent approach, both to collating data and to analysing it and then presenting it in a clear, transparent way. So the data library is where we have collated all the information that we could find from various impact assessments for marine mammals and seabirds and data that's needed to run tools. So it holds the key knowledge, parameters and data necessary for performing impact assessments in the UK. It has metadata standards and very consistent documentation, and also transparent version control to allow datasets to be updated as new information becomes available, or indeed as guidance changes. The second part is the integrative R package, which links the tools together, allowing us to combine across different impact types. It also allows outputs from one tool to become inputs for another to feed through that process, and allows us to assess in combination impacts across multiple wind farm footprints with a clear description of the uncertainty involved at each stage and how this is propagated from one stage to the next. We then have the user interface. This is an interactive interface which guides the user through the process. Various model options and parameters are embedded in the interface with guidance. And a key aspect here is that it produces this transparent, standardized, reproducible audit trail for each session in the form of a summary report. So in summary, the cumulative effects framework has been developed to address many of the key concerns that were identified by stakeholders at the start of the project. So we now have a fully documented, accessible data store for collated impact assessment data in the UK for seabirds and marine mammals. We have this ability to produce this transparent, repeatable and flexible framework with a clear audit trail. And we've improved how uncertainty is both quantified and propagated through the system and described at each step. And I think for us overall, a key outcome has been really to do with engagement, learning and trust. The project, because it's had this very extensive stakeholder interaction, has developed a community of really engaged participants, which has helped to build trust and understanding in terms of the different challenges that we face in terms of cumulative impact assessments. And this is really critical going forwards in terms of trying to meet our net zero targets in the UK. So just to finish then, we feel that the cumulative effects framework really provides a new platform that will greatly facilitate reductions in consenting uncertainty and timescales, because it's going to allow us as a community to move forwards with this cohesive development of transparent, standardised methods for impact assessments. Thank you very much. This is just a link to our project website and also email addresses for myself and project PI, Francis Daunt. Thanks very much.